Hey everybody, we'll jump straight into this one, the area of triangles and trapezoids. Hey, I'm wearing my new blue blocking glasses. I know it's a different look. I hope it doesn't distract you as we go through with this, but yeah, let's do this. So the height is always perpendicular, that's key. And then this formula, it actually works with the parallelograms too. It's just the bases don't change in a parallelogram. But the formula for all polygons is the average of the bases times the height. Let's see how that applies here. Here's a formula you should already be familiar with. The area of a triangle is 1/2 times the base times the height. It's always half of a parallelogram as a reason for that. But here's another reason why. Well, I'll explain that reason why here in just a second. So the height always has to be perpendicular to the base. So if you're going to make this side down here on the bottom, your base, the height is going to be the altitude that goes from the opposite point, opposite vertex, down to it and making a right angle. Here on this guy, if I make this side over here the base, well, the height is going to come from that opposite vertex and be perpendicular to it. Now, to be clear, this is a copy of this triangle right here, same triangle. If I say that this side is the base, that's fine. You can say that this side is the base, but it's going to come, the height has to come from this opposite vertex and be perpendicular to it. So it does not matter which side you use. You've heard me say this before, I'll say it again. The base is not always the one on the bottom. Don't make that a thing, okay? So it's 1/2 times the base times the height is how that works. We'll do these examples down here for a second. But let me first talk to you about this trapezoid, how the triangle is related to a trapezoid. So here's the base and the height of this triangle here. It's the same one from here on the left. Now I'm going to modify it. Check this out. If I take this side and I were to drag it a little bit of ways this way, take this side here, I'm going to drag it, it would end up looking like this. And if I drag it in such a way that I keep this side horizontal, it's going to make a parallel side up here, which all of a sudden now there are two bases, two opposing bases. I got a base down there, and those opposite bases are parallel, so this is now a trapezoid. I'm going to keep dragging this out. I got two bases. I drag it out a little bit more. Well, it's just a bigger trapezoid. I drag it out a little bit more. I got a bigger trapezoid. I got a base here. I got a base here. I'm going to call that base 1 and base 2. That I have just created this trapezoid from originally this triangle. I'm going to do that again real quickly here. Here's the original triangle. I'm just going to drag those sides out, keeping them parallel. It's now a trapezoid. I keep dragging it. That is now that same shape down here. So that's trying to show you that these are related. Here's the difference. Prior, when this was originally the triangle, this base up here didn't exist. Or if it did exist, its length was 0. So if I were to average this base and 0, I'll just be taking 1/2 of that one base. Whereas here I have two bases and I have to account for both of them. So the formula for a trapezoid, you see how it's the same, 1/2 times the base times the height. Well, I got two bases, so I have to take the average of those bases. And that's what the 1/2 does. 1/2 of two things added together is the average. Like the average of 2 and 4 would be 1/2 of 2 plus 4. So 1/2 of 6 is 3. The average of 2 and 4 is 3. So that's a way of doing it. Or you can just think of it as the average of the bases is another way of looking at the formula for this. So the two parallel sides will always be your bases, and we call the other sides the legs. And we're talking about a trapezoid. The parallel sides are the bases. The sides that connect the bases are called legs. Here in this example, the parallel sides, this is going to be the base. It doesn't matter which one you call base 1 and base 2. Base and base 2, base 1. And then the height will be perpendicular to both of those bases. So will form a right angle. There's alternate interior angles, all that sort of stuff happening there as well. Okay, so the two formulas are very, very similar to each other. The difference is this base is 0. So if you could actually apply this would, if you call this B1, B1 plus B2 just becomes B1. There's no, B2 doesn't exist. So it ends up being the exact same formula. It's just there's not a second base on a triangle. Okay, let's go jump to the examples here. My right angle is here. That's my height, going from the vertex down to the base. 1/2 times the base times the height gives me 63 units squared. This is an obtuse angle. There's my right angle, y'all. My right angle there, that my height is 4. That base is is 5. That side was extended. This is like those altitudes we've worked on drawing at some points in time. But this base is 5. The distance from this guy out here is 4. You just had to extend that side. So it's 1/2 times 5 times 4. On number 3, where's my right angle? Well, there is a right angle here because 5 squared plus 12 squared is 13 squared. That's a right triangle. So the right angle is here. And when you have a right angle, there is your base and your height. It doesn't matter which one's your base and which one's your height. In a right triangle, your 5 and your 12, or the two legs, one's your base, the other's the height. It doesn't matter the order. 1/2 times 5 times 12 is your, that's how you find the area. Number 4 gets a little bit more interesting. Where's my right angle? Well, we're going to have to create it here. But this is an isosceles triangle. This is the reason we did this in Unit 8 was for this. If my base is 12 and that those legs are both 10 degrees in isosceles, the altitude chops that base in half so that now we can use the Pythagorean theorem to calculate the height. Again, the isosceles triangle, the height, chops the base in half, the 12 becomes 6 and 6, and then you use the Pythagorean theorem. 6 squared plus the height squared equals the hypotenuse, in this case is 10 squared. The height is 8, so we had to use the Pythagorean theorem to calculate it. 1/2 times 12 times 8 is 48 units squared. Pay close attention to this example here as well. What's the area of an equilateral triangle with perimeter of 18? Well, if the perimeter is 18 and each of those sides is 6, I'm going to call this one down here on the bottom, the base. 6 is equal to the base. Just like this guy over here, these are similar, except now this is a 30, 60, 90 triangle. What happens to this 6 down here at the bottom? It becomes 3 and 3. Using 30, 60, 90 triangles, the height becomes 3 square root 3. So now it's 1/2 times the base, which was 6, times the height, which is 3 square root 3, and that gets me 9 square root 3 for the area. That's going to be an important one. We'll talk certainly more about that next class. On to trapezoids. So for trapezoids, the two parallel sides, it tells us these are trapezoids. They're not marked as parallel, but since it tells us a trapezoid, the two parallel sides are 5 and 15. Those are my two bases. The height's going to be the thing that's perpendicular to both of them. So in this case, it gives me B1, B2, and H. Just plug it into our formula and simplify, calculate. 1/2 times 15 plus 5 is 1/2 times 20 times, and then times the height is 3 is where that comes from. Number 7 is the same, it's just up on its side. The bases are 7 and 3. The height is the perpendicular connection of those bases, it's 10. So it's 1/2 times 7 plus 3 times 10. That's 1/2 of 10 times 10 becomes 50 units squared. Number 8, oh boy, do you see the deal here? Look at there, there's 60 degrees. Yep, we're going to do that. It gave us the two bases, is B1 and B2. Is 30 and 15. We're going to use those, but we've got to go find the height. We'll use the 30, 60, 90 triangle. 12 is the hypotenuse. The short leg is this little piece down here is 6 times the square root of 3. The height is 6 square root 3. So 1/2 times 15 plus 30 times 6 square root 3. Simplify, solve. 135 square root 3 is the area. And finally, the isosceles trapezoids. So the difference between an isosceles trapezoid and these guys up here is that the legs are equal. That's where the isosceles part comes from. 12 and 12, 10 and 10. And when you have an isosceles trapezoid, you will do this every time. You will create two right triangles and a rectangle like this. Okay, so my bases here in this example are 30 and 18. We'll use those legs to make a rectangle in the middle with two right triangles on either side. Okay? Now, because of the rectangles, well, my height is here. That's what I got to go calculate. But the rectangle is going to go like this. This 18 becomes 18 up there in the middle. And that leaves me with these two wings on the side that I got to calculate. So 18 plus those two wings is going to equal 30. Those two wings are equal. So 18 take away 30 is 12. Each of those wings will end up being 6. Now I have a right triangle on either side. They're both congruent. 6 squared plus 8 squared equals 10 squared. Hopefully you figured out that pattern. 6, 8, 10. The height is 8. We use the Pythagorean theorem in this case to calculate the height. I'll go through that one more time real quickly. We got the bases. Right triangles in left and right. Height is the leg of that right triangle. The 18 gets the 30 here gets split up by 18 plus these two other things. We calculate that to get 6. And then it's 6 squared plus the 8 squared equals 10 squared using either of those right triangles. Now that I have the height, I can use the formula and get the area. Number 10 is the same. It turns out we don't need the 60 degrees because we can do it the same way as we did the other ones. But with 60 degrees, it's fine. When this 12 follows up here to this 12, 24 minus 12 is 12, so this becomes 6 and 6. It won't always be 6. It just happened to be in these two. To calculate the height, I can use the 30, 60, 90 triangle, or I could use the Pythagorean theorem, I suppose, in this case. But it's 6 square root 3 is the height. But the key to the isosceles ones is the rectangle in the middle with the two right triangles. All right. Hopefully that's helpful. Look forward to hearing your questions. Okay, bye.